Hello and welcome to lesson 4.8, verifying geometric properties. So today what we're going to do is we're going to take a look at verifying some geometric properties based on some algebraic work that we're going to do. So the first thing we're going to do right here is we're going to look at the triangle ABC given by the points 2, 1 at A, B is -3, and C is at -4, -1. And we're going to show that the mid-segment joining AB to BC is parallel and is half the size of AC. So first of all, in order to find the mid-segment, remember that we got to find two midpoints. And they're specifically telling you the midpoints of AB and AC. So I want to calculate the midpoint of AB. So I'm going to take these two values of A and B, add the X values, find the average, add the Y values. Find the average. So 6 divided by 2 is 3. -2 divided by 2 is -1. I also want to find the midpoint of the point BC. I'll call this, that's going to give us 4 plus -4. And the point -3 plus -1 divided by 2. Okay. So these are my new points. I'm going to call this second midpoint Y. I'm going to call this first midpoint X. So now I want to prove that XY is half the size of AC and is also parallel to AC. Well, in order for it to be, first of all, parallel, that means the slopes have to be the same. So I have to find the slope of XY, and I also have to find the slope of AC. Well, I remember how to find the slope using our y2 minus y1 over x2 minus x1 formulas. So I'm just going to substitute the values in. So for A and C, that is -1 minus 1, and -4 minus 2. That works out to -2 over -6, or 1/3 if we reduce. Okay, so now I'll do the same thing for the other expression. For xy, -2 minus -1 over 0 minus 3. Well, -2 minus -1 is -1 over -3. This reduces to 1/3. As you can see, these slopes are identical and therefore parallel. Well, you might also notice that using what we have here as the slope here and the slope here, these pieces are actually part of finding distances of our expressions. So what we're going to do is we're going to use that information right here to actually find out the distance of these expressions. So I'm going to find the distance of xy using that x2 minus x1, which was 0 minus 3, square that, add that to -2 minus -1, square that. So using my calculator, I get 3 squared, which is 9, I got 1 squared, which is 1. This is the square root of 10. Okay, so now I'm going to find the distance of AC by the same process. Oh, I should actually calculate the value of xy, distance of xy, using a calculator. So let me actually figure that one out. So that's approximately 3.162 units. Okay, so now do AC. This works out to be 40, so square root of 40. Okay, so let's see what that value is. So square root of 40 turns out to be approximately 6.325 with rounded up, which you can see is double the actual side length that you actually are given. And therefore proving that AC is double the length of XY and that it's parallel. So let's write a concluding statement. Therefore, the mid-segment is parallel to AC and half the size. Therefore, proving what we wanted, and therefore verifying our property. Okay, let's try another one. Asks us to classify the shape PQRS with the vertices P being 2, 3, Q being -2, -9, R being -8, -7, and S being -4 and 5. Whenever they talk about a shape PQRS, it actually means that the shape, not showing that this works exactly the same, but, and not saying that this is what it looks like, but the letters PQRS go in a cycle like this. So that means you can actually determine which are side lengths, which ones are actual side lengths here. So what we're going to do is, in order to classify this shape, we can have various different shapes. We can have rectangles, we can have squares, we can have rectangles, so forth. What we're going to do is we're going to find both the slope and the distances between points. So as you might notice, this is just going to be a little bit of tedious work. And as we saw in our last case, working out slope first would help you actually find out distance. So let's find out the slope of PQ first. So after a while you start getting used to, well, I gotta subtract my y values first, and then I gotta subtract the x values. So here you notice that value is 3, so the slope is 3. At the same time, I'm going to work out my distance of PQ so that I can compare it to the other lengths. So after a while, you just realize you got to take your x values, square that, take your y values, square them. And I get square root 160, which is approximately 12.649 units. Okay, so there's PQ. Now that I got the shape and I know what point size to look at, I'm going to look at QR. That's my next one. So again, just put in your calculations. Okay, so the slope is negative 1/3 here. Again, I'm going to work out the distance. This one turns out to be square root of 40, which is approximately something we already found, which was 6.325, approximately. Okay, so far, the only thing I can notice right here is this slope and this slope are negative reciprocals of each other. So that means the angle at Q is actually a right angle. Okay, so now let's find out the slope of our S. Wow, we found out the slopes of PQ and RS are actually the same thing. Moreover, let's work out the distances here. Distances are the same. So that means the two sides are parallel, having the same slope and same distance. And also, it is perpendicular. So, you can prove it to yourself by actually finding the last length of PS and actually finding out that it is also parallel to QR and that it's perpendicular to both at P and S as the angles. So, what can we conclude? The conclusion of this is the shape PQRS is a rectangle. Just by determining if they're parallel, being certain side lengths, being the same size, and also the angles are 90 degrees. Now let me share with you that it is not necessary to actually find a third length if you actually know the three lengths, so you'll actually be able to figure out the fourth length just as easily and just realizing it. So it wasn't necessary to find. Thus concludes this lesson.